how many mistakes does a normal body make every single day? 10,000 mistakes. So why don't we get more cancer more often? That's the interesting question.
Yeah, I mean, if anyone needs any more information or evidence that food is medicine, well, there you go.
If you think about it sort of holistically, it's not food versus medicine. That's not the point. The point is, what about food and medicine?
Welcome to Commune. We are on a mission to inspire, heal, and bring the world closer together.
So I'd like to start by exploring our human understanding of disease and how it has evolved over the last couple of centuries, and specifically the role that bacteria has played within that evolution. And I'll just set it up this way. So until relatively recently, the prominent diseases that have plagued humanity have been infectious. I guess referring to the Black Plague or smallpox, cholera, infectious diseases that have literally decimated populations, killed hundreds of millions of people. However, in modern Western society, our primary nemesis, with the notable exception of COVID, which we can touch on, it's obviously the elephant in the room, but our modern primary nemesis are chronic diseases like cancer, heart disease, diabetes, Alzheimer's, and autoimmune diseases like MS, rheumatoid arthritis, Crohn's, intestinal bowel disorder, etc. So as a pathway into the conversation, maybe I'll place us in the Middle Ages for a moment, when we had no concept of microbes, and the prevailing theory was known as miasma theory, that posited that disease was caused by a pestilence in the air emanating from rotten food. But when and how did our understanding of disease and its relationships to microbes change?
Jeff, let me unpack what you're setting up just a little bit, which
Great.
is until we had even a germ theory, there was no understanding of why we got sick. And even more importantly, why we didn't get sick more often, which is what I want to get to, because my career has really been grounded on answering that question: is why are we healthy, and what's the secret to staying healthy? Because when it comes to well-being, which is defined by a lot of different types of healthy, right? So it's a convergence, how we feel. If we feel well, it's because we feel well in a lot of different sectors of our lives. What's responsible for that? But back to this idea of trying to find why we get sick. That's been really the center of medical science discourse for thousands of years. I think it's human nature, and we see this in today's world with a pandemic, to try to point fingers, right? And when I say point fingers, I'm not talking about politics. I'm talking about, we're trying to find what's the cause, that who did it, and why. And somebody is the guilty party, or something is the guilty agent. And that's really, I think, where the discoveries of Pasteur and other people that actually were able to reveal a microbial world that we previously didn't understand, and found that some of the microbes that were discovered early on were indeed pathogenic, meaning that they cause disease, they cause pathology. And that basically triggered another several hundred years of active research to identify, one after another, bad guys, bad actors, criminals that ruin the neighborhood. And I'll come back to why I'm saying that. And really trying to portray as much as we can what causes syphilis, what causes gonorrhea, what causes the plague, what animals transfer it, what happens when we breathe it in, why is it so bad? Can we find a tincture? Can we find an injection? Can we find a biotechnology? I've just went over 200 years that could actually knock out the bad guy, right? So we're always looking for that heat-seeking missile to destroy the lair of the terrorist that threatens us. Well, what I would say, and by the way, as a medical doctor, as an MD trained in internal medicine, that's how I was taught too in the 1980s and 1990s. That was the dominant philosophy, which is that bacteria are bad. Wash your hands. We have to scrub and sterilize everything. And indeed, honestly, going back a couple of hundred years, women died in childbirth because the one infected mom who wound up actually having her baby delivered by a doctor who didn't wear gloves and didn't wash his hands, wound up infecting the doctor's hands, who then went right to the next mom in the next bed who didn't have the infection to deliver her baby. And the doctor spread the bad germs, the bad actor, to that next mom. And indeed, about 30% of childbirths wound up in mortality, dying of either the baby or the mom, right? So again, there's lots of reason to think about bad guys. What's actually happened in the last, I would say 10 years, 15 years, but is really coming to a white heat now, Jeff, is this recognition that bacteria are not all bad. In fact, there are some bad actors, but really bacteria are in fact, by and large, good guys. They're useful. We coexist with them, not sort of a passive coexistence, but in fact, bacteria work for us. And this led to the idea of a healthy microbiome, of which a lot of it's in our gut, about 39 trillion members of our gut microbiome. And this ecosystem that we've come to appreciate better, we're just at the tip of the iceberg of understanding it, is a neighborhood. It's an ecosystem. It's like the Great Barrier Reef miniaturized and swallowed so that it lives in our gut. There are trillions of organisms that all collaborate, cooperate. They're good neighbors. And yeah, every now and then there's a bad neighbor that actually causes a problem. But as long as your neighborhood is largely made up by good citizens that support each other, help each other, loan each other the silverware when needed, et cetera, we're actually pretty healthy. And that's started to change our focus away from the bad guys to trying to understand the good guys.
Yeah, that's so helpful. And I love the terms that you leverage to frame the discussion, very much in the terms of a community. And I think the first time I ever read the word holobiont was, I think, in your book, but I've since, it's coming into the zeitgeist quite a bit. And this notion that humans are not just composed of human cells, but we actually live within a mutual interdependence within this community. And it's obviously there's many metaphors that one can draw between the micro and the macro as one begins to put a lens on societal dysbiosis, if you will. But I want to just focus on our also this kind of battle. These terms that we use are constantly kind of war, they're bellicose in nature, where we're always fighting against the bad guys. We're waging a war against bacteria. And for, I would say, most of the 20th century, if you go through some of these great discoveries that obviously had a tremendous beneficial impact, but turned into kind of the prescription of broad spectrum antibiotics, for example, or the overuse of NSAIDs or PPIs or even chlorine in the water, but antibacterial soaps, processed foods, chemical fertilizers, and herbicides and whatnot. And I'm wondering if you think that the Human Genome Project, maybe you could describe that a little bit and some of the revelations that came out of that perhaps birthed this emerging field of the microbiome.
Yeah, so the Human Genome Project, which took place over just a little over a decade, was this audacious project to dive into the genetics of our body, that every one of our 40 trillion cells possesses a secret, a Rosetta Stone that we didn't know even how to get at. We couldn't read the Rosetta Stone until Watson and Crick helped us unravel, so to speak, the the letters of the alphabet composing our DNA. But the Human Genome Project was just much more than reading a dead language or a language with a scroll we couldn't understand. It was really about trying to put function into the words of our genetic code, not just being able to read the prose, but to be able to understand what it means and what it is telling us or not telling us, as the case may be. And by sequencing the human genome, there's about 30,000 human genes. We know the function of many of them, but not all of them. And a lot of times people don't tell you this, but as somebody who studies molecular biology, and I'm very involved with genomic research, there are huge sections of our genetic code that might be likened to areas of highway in which, when you look to the right or the left out the window, there's nothing but fields that we don't think there's much there. There isn't a city, there isn't a house, but just empty fields, it looks like. But in fact, these kind of dead areas in our genetic code, we're still starting to realize that they actually have important functions. So identifying the Human Genome Project was really just being able to read not just the alphabet, but to be able to read the prose and put some, and just so we can actually begin to decipher what our genetic code actually means. And when we started to do this, we realized many of our genes that are units of DNA that make proteins that are the instructions to tell our cells and our organs what to do. All right. That many of those we had a final aha, like, that's what that gene looks like. We discovered new genes as well that we didn't appreciate before. And we also discovered new functions of genes that we thought we knew. So this is brand new, published in the journal Science just last week. Tumor suppressor genes, which don't sound like they should be a good thing, but actually a tumor suppressor gene is a healthy gene in our body that does exactly what it's named for. It suppresses cancer. And it was thought for many years that these genes, when they're working properly, prevent cancer cells from dividing and growing and accumulating and causing a problem. And so when you have a mutation in the gene for a tumor suppressor, BRCA1, BRCA2, P53, these are some of the words that scientists understand. And of course, Angelina Jolie made everybody recognize BRCA. When those genes are actually mutated, well, suddenly you lose a protection, you lose a shield. It's like taking off a bulletproof vest, and now you're wading out into the field of fire, and without that protection, you might actually get hit. And so that's what we thought for a few decades, including my research background, that tumor suppressor genes are. About 10 years ago, we discovered that tumor suppressor genes also do something besides prevent cancer cells from growing. Many of them actually cut off the blood supply, feeding cancers as well. 2 job descriptions with 1 gene. Okay. And last week it was discovered there was another function, which is amazing for tumor suppressors. That is a jaw-dropping discovery published in the journal Science. It shows that the tumor suppressor gene also is a governor, a switching mechanism that allows your immune system to spot cancers and to snuff them out. Therefore, when you have a mutation in your tumor suppressor gene, not only do you allow cancer cells to grow out of control, problem, you also allow blood vessels to feed the cancer, another problem due to this mutation. But now, and this is to me is like the big aha that's going to reverberate in the cancer research community. We now know that these mutations actually help the cancer disguise itself from your immune system to escape immune destruction. Now the cancer's escaped our health defense system, our immune system, and escaped our blood vessel system to control its growth. And so here's an example of how the Human Genome Project allowed us to actually uncover words, let's call it vocabulary words, that we didn't quite understand. And as we dig deeper and deeper and deeper into it, we're beginning to even understand more meaning to the words, a new definition to the words as well. Now, how do these genetic discoveries lead to something more? Well, number one, we understand it's not just we're born with these genes and there is the fate that we have. We inherited from mom and dad. But in fact, our life experience, what we eat, what we do for work, who we meet for a living, bacteria that we actually accumulate as we roll in the dirt, we go diving into an ocean, or that we drop an ice cream cone and decide not to throw it up, but take a bite of it, that all those factors start to cause epigenetic changes. This is taking your gene and slightly altering what it actually does to generate something else. Sometimes it's better. Sometimes it's worse. So, we are this big tangled ball of yarn from a knowledge perspective. And what's exciting for me as a medical researcher is really being able to contribute a bit to unraveling this ball of yarn and trying to figure out and help other people understand what it is that is not just interesting to scientists. There's so much interesting to scientists, but what can you actually do for yourself with your food? And that's what I wrote about in Eat to Beat Disease, is what's practical that you can use that can help you.
Yeah, fascinating. I'm going to read that study if you'll send me a link to it.
Absolutely.
And this is, there's a saying, the more light, the bigger that you build the bonfire, the greater the amount of darkness is revealed, right? And this is the inexorable march of science and discovery and innovation that's so fascinating, is that the more we learn, the more that we realize that we don't know. And just to be on the cutting edge of that is so exciting. And I was so grateful for your work there. And so it's interesting when you talk about a tumor suppressor gene, for example. One of the things that I believe that we learned was that that the human cell is not always the center of human health. And I say that in regards to that other agents, microbes, for example, can alter or trigger gene expression in a particular way. I'm not sure how these particular tumor suppressor cells are regulated, but certainly there are plenty of examples within essential bodily systems that are not regulated by the human genome, but are regulated by the microbial genome. So maybe you could take a moment to, take a step back and address the nature of the microbiota, what it is, and then what systems it seems to be able to govern within the human body.
Right. Okay. So perfect, timely question, because the answer to the question I've been asked, which is what is health? And the answer I used to give, which is, well, if I'm not sick, I'm healthy. So health is the absence of disease. We now know that that's not true. That's not the right answer. It's the answer that many people give. But the answer to the question, what is health? Health is not just the absence of disease. It is the result of our body's hardwired health defense systems that are firing on all cylinders to protect our health and repel disease from the time we're born all the way into our very last breath. And throughout the journey of our life, these health defense systems, these are biological systems that are inside our body. And the microbiome is one of those health defense systems. They actually are hard at work all day long, 24/7. They respond to what we do to ourselves. I'll talk about that with the gut bacteria in a second. And when we treat our health defenses well, they function to protect our health. And when we hurt our health defenses, and meaning that we take in chemicals, or we actually don't exercise, or we don't get enough sleep, we disadvantage our health defenses. Well, not surprisingly, we actually get more likely to get sick. And so what I think is really quite remarkable is this new era of discovery that our health is defended by biological systems in the body. When you talk about food and health, it's not just about the food, it's about how our body responds to what we put inside it. And our body being human and our body being bacteria, now here's where it actually gets to the microbiome. So first of all, we are filled with and covered by bacteria, which is really good. So, if you're getting ready, primping up, getting dressed, combing your hair, getting ready for a night out for a weekend, no matter how good you look in the mirror, you're covered with bacteria. Okay. That's just because that's now we realize our skin, our ears, our nose, openings of our mouth, even on our tongue, filled with bacteria, healthy bacteria. We want those bacteria around. And inside our body, by the way, we got bacteria as well. Where did most of us get our first bacteria? When we crawled up our mom's body, or the obstetrician laid us on our mom's naked chest, and we went for the nipple to get our first meal, breast milk. Okay, that's actually where the bacteria from the skin and also some bacteria in the milk get into the baby's gut. For those babies who are not breastfed, they still got bacteria from their mom and their environment just from touching her skin. So we are intimately connected to our parents and our mothers based on the bacteria that then populates us. So this is not something that we pick up late in life. This is something that we actually, even in the womb, the bacteria are starting to form, and then they start to grow and groom and build themselves out over the course of our life. Now, how many do we have in our gut inside us? About 39 trillion. Now, that's not an exact number. Let's call it rounding up. But there's about 40 trillion human cells. So you're talking about 1-to-1. The whole term of holobiont describes an organism that's composed of more than one species. So an entity, remember back a few decades, they were talking about cyborg, part human, part machine. Well, we're not cyborgs. Well, maybe some people are, but they've got enough hardware put in them. But we're holobionts, and holobionts holobiont is kind of like the biological counterpart to a cyborg, instead part human and part other species. In this case, bacteria. A lot of it grows in our gut, and if you think about the gut like a garden hose. Okay, it's like 40 feet long. The tail end of it's like our colon. That's where a ton of bacteria is. And the bacteria fills up our gut. And they live along the walls of our gut. Here's something amazing. When we feed ourselves, so we're sitting down eating dinner, eating something that's hopefully good for us, mostly plant-based foods, different kinds of proteins, ideally healthy proteins, and staying away from the harmful stuff. Our body, our stomach, our small intestines, digests and absorbs a lot of the nutrients that our human cells need. Now, when I was in medical school, we were taught anything that's not absorbed by the human just rolls down to the end of the gut and you poop it out, right? I mean, that is stool, feces. You see that when you're hiking on a trail and you say, the moose must have been here. Okay. Well, that's not really true anymore. We realize that whatever the human body doesn't absorb does roll downward, but then whatever we don't eat first, we're feeding our gut bacteria. What do they eat? They eat the bioactives found in plants. They eat the fiber, which is the prebiotics. They sometimes collaborate with the bacteria in our food as well, and that actually alters and fortifies and stimulates and activates our gut microbiome, and they thank us for it. Our bacteria are so grateful for the good things that we give them that as a token of thanks, they pay the bill for feeding them by creating metabolites. So they generate their own chemical signals, and these chemical signals dissolve out of our gut. They get into our bloodstream, and man, do they do things. And this is the exciting part. They make our insulin work better. So it streamlines our metabolism. They lower our blood lipids so our cholesterol doesn't have to be so high. They help heal our wounds so that if we cut ourselves, we speed our healing more quickly. They help us maintain our adipose tissue, our fatty tissue. They prevent big, bulky boluses of fat from accumulating inside the middle of our body cavity or into our gut. And they help to streamline what we're doing. They help our blood flow. And amazingly, some of these bacteria seem to be able to send a text message through our nervous system from our gut to our brain and tells our brain to release neurotransmitters and hormones, social hormones. So, dopamine, serotonin, these are the things that, like if you were seeing a psychiatrist and you needed medication, you get a prescription for this, okay? Our gut microbiome writes that prescription every time we eat. It's amazing. Amazing. Another amazing hormone that the gut microbiome tells the brain to release is oxytocin. Oxytocin is the feel-good social hormone. So, if you've been isolated from your friends for a year and a half during the pandemic, and you finally get to see your friend, and like you give them a big hug, all right, or a relative, you're a grandparent, or a nephew or a niece, you give them a big hug. That feel good that you have when you have human contact, that's oxytocin pouring out of your brain. Oxytocin is also when you have a kiss, that romantic kiss, brain flooding is oxytocin flooding out. When you have an orgasm, your brain releases massive amounts of oxytocin for a few seconds. Okay. Your gut bacteria helps make that happen. Amazing.
That's incredible. I think I've read that 80% of the serotonin is upregulated by the gut, or produced by the gut, by bacteria in the gut. And I think this is actually a good time to delineate between prebiotics, probiotics, and postbiotics, because I think when you're referencing the metabolites, in some ways you're referencing these short chain fatty acids, which are also known as postbiotics. But there's so much jargon within the world of the microbiome that I think for people to understand the delineation between pro, and postbiotics, I think that would create some clarity for people, including myself.
Yeah, sure. Look, this is a new field of science. And so just like when astronomy was still new, we didn't have the full vocabulary to describe what we saw in the starry night, right? So to some extent, we are still trying to find categories that we can actually put a picture frame around, a definition around, right? So here, I'll try to boil it down to how most people think about it and give you a little bit of the caveats that we in the scientific world are also working on. So if you think about the gut bacteria as the microbiome, so this is the world, the neighborhood that's living in our gut of our microbiome. So the prebiotic is whatever is coming to feed the gut bacteria. And so we see these as high fiber foods, soluble fibers, a lot of actual bioactives as well. So some of the polyphenols actually have a positive, very big positive effect on our microbiome as well. So we don't want to blow that off. It's not all about fiber. The actual bioactives are also quite important. And the bacteria eating this food that we are actually giving to them by eating, they don't eat alone. They have communal dining. So basically our gut bacteria is in our gut is like a giant cafeteria. And so when we feed them prebiotic foods, they're sitting with their friends and everybody is sharing the meal and deciding, hey, you want to try some of this, or here, have mine instead. And so just like a community working together, the magic that comes out of a group meal is different than actually sitting alone and dining alone. So when we talk about individual bacteria eating specific foods, what we need to realize is that actually it's not, even though we research it that way, people try to find this food will feed that bacteria. That's a reductionist thinking. Really is that, we're eating a meal of complex foods, and there's a lot of prebiotics, a lot of fiber, a lot of bioactives in the food that we eat. We absorb it, then we bring it down to the cafeteria, and the gut microbiome kind of digests it. Now, this communal eating, the group of bacteria, they actually are the microbiome. And so sometimes we add bacteria to what we eat as well. And amazingly, what we're feeding the bacteria, which includes bacteria like cheese, for example, you can actually, if you take cheese, which actually has some healthy bacteria in it, some kinds of cheese, and you eat it, they'll tumble down through your gut, and they will actually they'll just get off and they'll pull up a chair and sit in the cafeteria. Okay. And they'll start having a meal too. And so I think this analogy that I'm trying to give to make everybody understand how, on one hand, complex it is, but on the other hand, we can understand it pretty easily. Prebiotics, probiotics are actually contributing bacteria. By the way, I used to scratch my head and say, well, how can bacteria survive stomach acid? How can bacteria make that long journey of 40 feet. Like it's impossible. That's what we were taught in medical school, back in the Stone Age. Now we realize it's very possible. These bacteria are actually able to get right through the stomach. They survive digestion. The right ones survives digestion, and they can make their way all the way down to the end. And you can even recover some if you take the stool and do a bacterial test, which, by the way, is how we test our microbiome. You can eat something and you can measure it at the very end. That doesn't normally appear in the gut. So we know this is true. So prebiotics, probiotics, you're eating the bacteria, and it could be in food. It could be actually in a supplement, probiotic supplement. And postbiotics is an interesting concept. I think it's much less well-defined. Postbiotics could be the metabolites created by the bacteria. So, in the cafeteria, they're talking a few of these. I'm going to use kind of like an analogy, an entrepreneurial analogy. A bunch of smart people get together over a meal, and they've got a napkin and a pencil, and they're talking about all the ideas. They get a great idea, and so they scribble down on the back of a napkin a business plan. Let's go create this thing, and then they like send off their napkin over to leave it for somebody to pick up to create a business out of it. Well, that's basically what these part of the postbiotics are. Your bacteria creating something new from the food you sent them during this dining period, and now that idea, in this case, it would actually be actual short chain fatty acids as one example. There's many more postbiotic, like what the bacteria produces, that get into the bloodstream. You got short chain fatty acids. We think about 3 of them: propionic acid, butyrate, and acetyl. So these are 3 different types of well-known postbiotics, and these are the ones that get into our bloodstream, and they do all those magical things that we talked about. These incredible organ, they influence our hormones. They organize our body functions, and I want to tell you one additional thing, which is that how sensitive our gut bacteria are, because the example I just gave you is all based on eating good things that the bacteria would love to have. When we actually when we eat substances that are not good for us, our body doesn't like it. We used to think about like the harm for the body, like an artificial dye, a food coloring, preservative that's harmful, a toxic chemical. Well, guess what? Now we're feeding the bacteria. They're getting what I'm absorbing is getting delivered to the cafeteria with our bacteria. Now the bacteria are descending and eating them, and guess what? It can poison all of the bacteria. When those bacteria die, the postbiotics aren't being made, or sometimes some of the postbiotics that are made when we feed them something bad are harmful postbiotics as well. So postbiotics aren't always good. Hydrogen sulfide, which, by the way, makes for a powerfully smelly fart, actually is an example of a bacteria product, a postbiotic that's not that good for you. So something you ate disagreed with the bacteria that then generated lots of hydrogen sulfide, which is the same smell as a rotten egg, right? And so, and that can be harmful. That can be reflecting harm. So prebiotic, probiotic, postbiotic, and then there's a whole other concept, which is the environment in which the bacteria grow. Many helpful bacteria, Jeff, grow in the mucus, the natural healthy mucus in our gut. Our gut is not a dry tube, like a cardboard tube of a paper towel. It is a flexible tube that is well lubricated with mucus. So whatever is in there can actually slide down where it needs to go. The bacteria have special ways of hanging on. So, they're seat belted to where they need to be. That mucus can really help certain healthy bacteria grow. So some of the foods we eat actually help the gut secrete more of that healthy mucus, which then allows the gut to grow more. And so there are also foods that are not just feed the bacteria like a prebiotic, but also create a more fertile environment so that more healthy bacteria can thrive. It's like putting fertilizer into your garden so your flowers are more beautiful.
Yeah, and associated there in the gut right there is a is the majority of the immune system, right? And so a lot of these short chain fatty acids or postbiotics are regulating immune response. So maybe you could talk about the maybe you would categorize that as the next town over or a neighbor of how of how the bacteria is regulating immune response, because obviously that's on the top of everyone's mind right now.
This is very exciting and very important. Where does the immune system live in the body? It's so important for our survival. Where does it actually live? As doctors, we were long taught that they live in our lymph nodes, they live in our spleen, a little bit in our bone marrow. Right. But that's not the whole answer. The fuller answer that we now realize, 70% of our immune system lives in our gut. And where do they live? They live within the wall of our gut. So think about, again, your gut like a tube, and within the wall of the tube. If you cut a garden hose, there's the wall of the garden hose is pretty thick. The immune system lives within the wall of the gut. It's like the jelly in a jelly roll. Okay. And the bacteria is in the middle of the tube. And there's not a lot of separation. They live very close to the immune system. I give the analogy, it's like college roommates in a dorm with thin walls, right? So, people are shouting to each other, telling what they want to order for pizza that night by shouting right through the wall. And that's what our bacteria is able to do. Our bacteria can talk to our immune system and give them instructions. And that's really what's important, because when we do well by our gut bacteria, they give the right instructions to our immune system. When we actually harm our gut bacteria, and maybe it'd be important to kind of touch a little bit on what are the things that harm gut bacteria. When we harm them, they are not actually giving the right instructions to our immune system. They're either not giving enough instruction or they're giving the wrong instructions. And if there's any health defense systems in our body that we don't want to actually have wrong instructions from, it's our immunity.
Yeah, that's right. I mean, I've read about how the microbiome can regulate Tregs, like T cell regulator cells that can keep the immune system from over responding and running amok. And when we don't have Treg cells that, operating properly, that can lead to autoimmune diseases, et cetera. But yeah, I think this is a good opportunity because what you described before was a very amicable, affable community family style dinner that's happening in the gut.
Right.
When your aunt gets a little bit too drunk and the topic turns to politics, things can go off. And right. And we can delve into what is dysbiosis, and then by extension, how certain bacteria and toxins can contribute to intestinal permeability, which leads to low-grade chronic inflammation. So maybe you could pull on that thread for a minute.
Yeah. Okay. So we painted this picture of how important bacteria in our body and how abundant they are, and why they talk to our immune system, and they also create these postbiotic short chain fatty acids that actually can influence our brain to our metabolism and everything else. That's a rosy picture of the body at its best. And our gut bacteria and our immune system are just two parts of our 5-prong health defense systems, which include our circulation, our stem cells, and our DNA's ability to protect itself. So what happens when the cafeteria becomes rowdy or unruly, or when there's a gang of ruffians, when the gangbangers enter the cafeteria? I mean, pretty much all hell breaks loose at various levels. So, the relatives striking a heated political debate makes everybody a little uncomfortable at the table, right? So you went from a happy meal to kind of like, oh man, can't believe we're talking about this. That's mild discomfort, right? So think about mild discomfort in your gut. Something's not agreeing with that community in you. It can be pretty mild in passing. You can actually have much more severe disagreements where, now somebody at the table picks up some food and they start a food fight. They start throwing things. All right, now if it's a more severe kind of problem, and now you're not talking about, it's not civil anymore. Now it's actually, like those are fighting words, and so now it's becoming unruly. It's and the homeostasis or healthy existence of the gut bacteria that's important for health can be disturbed, and that disturbance is called dysbiosis, getting away from that balanced biological harmony. It's not, a healthy cafeteria anymore where everybody's eating and having polite conversation. It might not even be a political argument. It may not even be a food fight. It could be an all-out brawl. Okay, and the more you brawl, the more toxic the environment becomes, truly, from the bacteria perspective. And some bacteria actually wind up, generating these toxins. It's kind of like that cafeteria. Like, hey, you know what? I had no idea someone's going to pull a gun. All right. And now all of a sudden you've got a few players that are actually acting up in a dysbiotic environment that are really causing a very dangerous situation. Some of those toxins, by the way, literally cause our gut, which is a watertight tube. Think about that. A watertight tube, because we're drinking water. It's flowing all the way through our body. We cannot have a leaky gut. Otherwise, we're going to have all kinds of problems. We don't want bacteria to be leaking into our bellies. That would be a problem. And yet that's what happens. This food fight, this dysbiosis, these bad actors, somebody pulls a weapon. And now the wall of the gut is disturbed, inflamed. And now when it's inflamed, it's leaking. When it's leaking, man, now you've got the stuff that's the food fight is actually leaking out into the belly, into the internal cavity of your belly. And literally, when I say leaking, these food particles, which are fine, they might have tasted great, when they leak out into our body cavity where they don't belong, causes intense pain, intense inflammation. Our body responds violently sometimes. And this is what we're, by the way, seeing in irritable bowel syndrome, inflammatory bowel disease, cancer of the gut can also cause this. And by the way, now think about those critical immune cells that were in that gut lining. They're getting leaked through as well. They're also being damaged. Now your immune system is like, should we attack these? Should we calm them down? We don't even know what to do anymore because it's so crazy. A fraternity party gone wild. Okay. And this is what gastroenterologists are dealing with, gut doctors, when patients are saying, man, for the last decade, I haven't been able to eat a meal without feeling crummy. This is what we're realizing is behind all of this, our gut bacteria not being treated well. And it's so easy, by the way, to make our gut bacteria unhappy. It's when we eat healthy foods, forget about what you watch on television or read about on the internet. It is actually true. Mostly plant-based foods, whole plant-based foods, nuts and legumes, healthy fats, moderate amounts of red wine and other, healthier versions of alcoholic beverages, coffee and teas. They actually all help feed the microbiome. They provide some modicum or a lot of prebiotic. When you start adding some of those chemical ingredients that you can't pronounce on the side of a box of an ultra-processed food, or artificial sweeteners, or a synthetic food coloring, or overabundance of added sugar, I can tell you that the gut bacteria does not like that. And we quickly start creating chaos in our gut. Now, if we don't overwhelm our gut bacteria is they're pretty resilient. So it can tolerate a little bit of disturbance and it'll try to right size itself. It's just like a community,
And it can bounce back relatively quickly when properly nourished and maintained, which is the good news, I think. Is that right?
That is exactly correct. And so people and even people who have actually had years of dysbiosis, what people need to understand is that we're beginning to realize our body has the ability to bounce itself back. And one of the things that I think is an exciting breakthrough area of medicine is we're realizing throwing pharmaceuticals at the problem may not be the right solution. We should be rethinking how we deal with the gut. Instead of masking symptoms, maybe trying to restore the integrity of that gut community. to begin with.
Yeah, I call it, we seem to be focused on watering the leaves and not the roots, where we're always addressing the symptoms and not the root cause, of course. And, it's obviously processed foods and sugar, but there are also other inputs that can degrade the eubiosis of the gut. I mean, I think about stress right now. People watching, 24-hour news cycle, which is geared around human negativity bias to trigger certain kinds of rage and anger, that keeps us in this constant sort of amygdala hijack, which of course has a hormonal component to it, which your body is soaked in cortisol and epinephrine, which was, had utility on the Serengeti, but not necessarily in chronic form, psychological form in the modern age. And of course, cortisol can also have an impact on the gut. And then, the overabundance of NSAIDs in our I wouldn't even call it diet, but in terms of, treating inflammation with NSAIDs and PPIs. So there's the gut, when we're not paying attention, it can be under assault from multiple flanks. And when we develop conditions like intestinal permeability and you have these lipopolysaccharides and other toxins seeping out into the bloodstream, the immune system sends out a response to trigger inflammation. And now, oftentimes people think of inflammation as a good thing. And perhaps this is a moment where you could address the difference between acute inflammation with an injury that requires some degree of angiogenesis and healing versus chronic inflammation, which seems to have quite detrimental impacts.
Yeah. So this is something that I really have spent my career researching and trying to tease apart. So inflammation is a component of our immune response, our immune system. And it was designed in order to be able to protect us from things like injury, where if we cut ourselves or we scrape our knee or we have have surgery or have a big traumatic wound, the bacteria that can enter from the outside world, our body is kind of anticipating that. So when we actually have this break in the skin, one of the almost immediate, like I'm talking about within a minute or two, responses, a knee-jerk reflex that our immune system has is to send out inflammatory cells right to the site of the injury to essentially be ready to block and tackle any harmful invaders that might come from the outside. It could be an insect, it could be a bacteria, it could be a virus, could be a fungus, could be whatever it is. Those inflammatory cells know what to do. It's kind of like sending out the infantry to the front lines. So they're all trained what to do. They all do the same thing. They're out there blocking and tackling. But in a wound, what actually happens is that inflammation, which might be around for a day or two. By the way, how do you know you've got inflammation after you get an injury? Well, you get that, let's say you scrape yourself, you get a little bit of swelling right along the injured area, little pink, puffy, pinkish redness. That's inflammation. Happens within a few minutes. And usually by the next day or so, it goes away because our body knows after it's cleaned up the breach, time for the infantryman to go away. We got to heal things up, heal it up with all the angiogenesis and blood vessels growing and repair and regenerate that tissue. So inflammation is a really important part of staying alive, but it should be there for a little bit and then go away. And the body knows how to turn it up and turn it down. It's kind of like a volume switch. Turn it up, and then when you've heard what you need to hear, turn it back down. Really, literally, inflammation is a day or two, and that's about it. Now, that's what it's supposed to do. When you actually have chronic inflammation, leaking gut, dysbiotic, gut bacteria microbiome, chronic stress that leading to all this inflammation, as you so beautifully described. Now you've got inflammation that is not only is it not directed and targeted to an area of injury, it's everywhere. Now your whole body's inflamed. Okay. And that's not a good thing. When your whole body's inflamed and there's no specific injury, it's just looking everywhere for a problem, and it doesn't back down. Now those inflammatory cells, which are really good at releasing toxins, cleaning things up, moving out the bad cells, now they're just doing their job, kind of releasing digestive enzymes and natural killer things everywhere and gobbling up debris everywhere in your body. That tends to degrade our health. It degrades our healthy function. And there's no way to turn it off. And in fact, what we want is our body to be able to turn it down. A healthy gut microbiome was one way of turning down inflammation. And instead, what medical doctors have been doing for decades now is just prescribing steroids. Let's just shut that baby down artificially. Right. All right, well, now you've actually tamped down your whole immune system and potentially altered your microbiome as well. Sometimes we have to do it, but that's not we shouldn't be reaching for that right away. Or we're actually using NSAIDs to calm inflammation. Well, that's fine, but it doesn't treat the root cause. So you're just kind of you're just actually taking a squirt gun to a forest fire. Yeah. We're definitely not putting that baby out. So so these are some of the harms of chronic inflammation.
Yeah, and it seems that low grade or even middle grade chronic inflammation seems to be the underwriting a lot of these big killer chronic diseases that we alluded to when we started our conversation, where now what we're looking at is, epidemics of heart disease and cancer and type 2 diabetes and Alzheimer's. And, not to poke the bear of COVID too much, but it's always, the elephant in the room. And, when you look at the comorbidities that are associated with folks that contract aggressive COVID, that results in either hospitalization or, in some cases, fatality, those comorbidities are the same ones that are underscored or supported by this chronic inflammation. So, when you look at society and the prevalence of metabolic syndrome, of high blood pressure, high glucose levels, of high deposits of adipose tissue, et cetera, you can trace that right back to lifestyle inputs, whether that's environmental or diet or nutritional, whether it's stress or, overprescription of broad spectrum antibiotics. So I'm wondering if you could tease one thing out for me, because I'm just a lowly podcast host with not a lot of letters after his name. But one of the ways that the immune system triggers inflammation are through these signals called cytokines. And cytokines have become sort of popular among us moonlighting microbiologists because there have been cytokine storms have been the cause of some of the COVID deaths. And to me, what it seems like is that we're living in this constant state of agitation where our immune system is agitated and might overreact to the presence of a virus and create a cytokine storm such that would trigger cell death in the tissues of the lungs that then fill with fluid, and people ended up dying of hypoxia or pneumonia and can't get oxygen to the heart, et cetera. Do you see a connection there between inflammation and those who seem to be most deleteriously impacted by COVID?
Right. Well, so I actually am a COVID researcher because I was one of the people very early in the pandemic to help to gather tissue from people who died of COVID and do the analysis to understand what's going on. And what I would tell you as a actual COVID researchers that there's still a lot we don't understand about the disease, because it clearly does more than cause the garden variety infection, even a serious garden variety infection. So we're still trying to figure this out. What I will say, though, is that, remember we talked about, the breach of the defenses and the body's immune response. That can also happen if you breathe in a virus and the virus sets up in your lung and starts to infect your cells. Look, that's a breach of the defenses. Our natural knee-jerk response is to really send out inflammatory cells, a little bit of low-grade inflammation to clean that out. If the infection is very aggressive, you're going to send more inflammatory cells out there. And once you have the buildup of the infantry out there and they're firing ammunition blindly, you can cause quite a bit of damage. So small inflammation getting to bigger inflammation is kind of what we're seeing in some cases of severe COVID. And it's not just COVID. I mean, I think that we're seeing this even in severe influenza or, COPD or some of these other lung diseases that we actually are much more common. Smokers' lungs probably have something similar. One of the problems that we're actually seeing with COVID that's become kind of a buzzword is cytokines. So these inflammatory cells, immune cells, are setting up, and what would be normally a relatively minor mission to help clean up the lung winds up becoming let's call it a battlefield. And in fact, it might even be better called a crossfire, where there's so much ammunition being sent out by our immune system in the form of these cytokines, which then attract more. Call in more ammunition. We need backup support. We need air support. And basically, this is what's actually happening until it's just this mess of a battle from our immune system, our inflammatory system. Definitely chronic inflammation starts in the lung, but it seems like it can go in other parts in the body as well. And those cytokines, which then reach astronomical levels, really become part of the problem. So this is really kind of your body's defenses gone haywire. We see something like this in autoimmune diseases as well. And in fact, we think that the long COVID that some people suffer from months after having acute COVID and recovered from an initial bout of COVID may also be due to this sort of just this continued battle that's actually going on with these cytokines being flown around. So you get this autoimmune kind of response. So what do? I mean, do you throw a steroid at it to shut it down? Do you actually use diet and lifestyle? What's the role of the microbiome? Can we reset that? These are some of the big outstanding questions that are out there. I'm one of the people looking at ways to improve the body's response after any kind of infection. And hopefully we're going to learn something useful from this episode that mankind has gone through over the last couple of years, and we might be able to actually use it for inflammatory bowel disease or irritable bowel syndrome, or maybe even cancer or other lung diseases as well. So I'm hopeful that the fringe benefits or the dividends of the research we're doing now are going to pay off in other diseases.
Yeah, I mean, certainly there does seem to be an interesting future for messenger RNA vaccines, for other kinds of applicability for them, and yes, obviously the relationship between inflammation and viral disease, et cetera. I mean, this is just hopefully an opportunity, as you say, some of the silver lining there that we can apply in the future towards sane public health. I want to just take a moment, if you have time, to address cancer, just because this is an area of work where you've done, or an area of study where you've done a lot of work. And some of the new emerging immunotherapies around cancer and its relationship to some of these immunotherapies' relationship to the microbiome, because I think it's fascinating, and just how we can eat to beat cancer both in conjunction with conventional therapies, but also in relation to some of these amazing new immunotherapies.
Right. Well, all of us know somebody who has been touched by cancer, maybe even a close family member, and all of us associate cancer with being this fearful, possibly terminal disease, where the treatment is actually perhaps even more scary with chemotherapy. So that's been imprinted on us. But the work that I've done in cancer research and the understanding of cancer today is changing that terrain and that landscape and changing the culture of thinking about cancer as well. First of all, let me say to your listeners and viewers that we are all forming microscopic cancers. We all have cancer in our body. Right here, right now, we've been forming cancers in our body since we were kids. Think of cancer like a pimple. They form all the time. Sometimes you see them in the mirror. Sometimes you don't. Sometimes you go through a phase in your life where you see more of them and then they don't form anymore. Sometimes a pimple forms in your butt cheek and you won't even know about it. Okay. And basically the idea is that our body is composed of 40 trillion cells. They are dividing to maintain themselves. And when they make a mistake in dividing, that's a mutation. It's a setup. One or two little mistakes is a setup for a mutant cell that when it replicates itself, divides itself, copy pastes itself, can be a microscopic cancer. And these little mistakes are really the root cause of why cancers actually begin. If you smoke cigarettes, you're going to make your lung create more mistakes. If you, if you lay out in the sun and if you go to a tanning booth, you're going to actually create more mistakes in your skin, and that's why you get melanoma. So cancer is not that much of a mystery. It's mistakes that are being made. Now, what about somebody who's living the good life and trying to be as healthy as possible, still makes mistakes? Your body still makes mistakes because there's 40 trillion cells dividing all the time. They're going to make some mistakes. It's like even if you're the best typist and you're typing your term paper, you're still going to make a couple of errors. Good news is that your body has spell check and actually can fix those mistakes without you knowing it. So how many mistakes does a normal body make every single day? 10,000 mistakes occur in our body every single day. That's the estimate based on how many cells we actually have. Now, so there's 10,000 shots on goal for a microscopic cancer to set up every day. So why don't we get more cancer more often? That's the interesting question. It's partly because our body actually has the ability to prevent cancers from growing up. So a microscopic cancer cannot grow larger than the tip of a ballpoint pen. Let me just show you one. This isn't a ballpoint pen, but here's the tip of a pen. That's as big as a cancer can actually grow without a blood supply. Just doesn't have enough oxygen or nutrients. Once blood vessels get there, if a cancer can hijack your blood vessel, give the blood supply, it can grow 16,000 times. That's the size of a basketball in just 2 weeks. So our body's ability to protect itself, defend itself against cancer involves our ability to control angiogenesis. So we're not able to, so the cancers can't grow blood vessels. Healthy cells can grow blood vessels, cancers can't. So that's one defense. And so basically these little microscopic cancers are sitting around in your body, okay, like this. And then what happens is our immune system, they can't grow our immune system, healthy immune system, communicated by a healthy microbiome, which responds to what we eat and how we're stressed and other environmental factors we've talked about. That immune system will wing by, kind of just doing, it's like a beat cop on patrol, finds these little guys sitting around and takes them out. Basically says, hey, that microscopic cancer, not a good guy. Let's remove him. So our immune system knows how to take care of cancer. That's what it's hardwired to do. That's why we don't get cancer more often. Now, immunotherapy, and when you actually have a cancer that's rip-roaring, diagnosed, breast cancer on a mammogram, or colon cancer and colonoscopy, prostate cancer with a high PSA, brain tumor by MRI of your brain. I'm a doctor. I see this all the time, and I'm involved with cancer patients. That's because that cancer, that tumor, has been able to evade, grow blood vessels to it, figure out how to hide from your immune system, explode in its growth. And by the way, if your microbiome isn't healthy, your immune system has trouble finding those cancers, most microscopic tumors. Well, if you're eating foods that trigger blood vessels to grow harmfully, you can also feed your cancer. So what do you want to do? You want to actually eat foods to prevent blood vessels from feeding your cancer. And if you need a treatment, there are biotech treatments that I help to develop that do that. If your immune system is down, you need to fix your microbiome. Like that's the first thing I always talk about. But then you actually sometimes need to give some help to your immune system. Enter immunotherapy. These are a new approach to treating cancer that doesn't generally kill the cancer itself. What it does is it powers up your own immune system, or even uncloaks the cancer so that your immune system can find the cancer and wipe it out. That has completely transformed our ability to fight cancer, because most immunotherapies do not have the side effects of chemotherapy. You're not trying to poison the body. All you're trying to do is to empower your immune system to do what it normally does.
Yeah, it's amazing. And of course, chemotherapies degrade the immune system, and then that can lead to all sorts of other cascading effects. And I think it's fascinating that we have these B and T cells that are on patrol, as you say, just kind of roaming the body. And when we have an upregulated immune system and everything's functioning in eubiosis, those B and T cells have a better opportunity at fighting cancer, and we just rely on our own immune system, to beat back, what is otherwise just a very scary concept for people. But also, I think one of the fascinating things that I read in your book was that these cancer cells are quite insidious and sneaky, and they have the ability to sort of cloak themselves to not appear as detrimental as they are. And that certain immunotherapies, like with checkpoint inhibitors, in combination with, I think it was Akkermansia, which was a particular kind of beneficial bacteria, that when you can upregulate both of those things, as far as I understand, the cancer sort of connects to the checkpoint on a T cell and sort of disarms it, and then this checkpoint inhibitor kind of reinvigorates the T cell in order to do its job. And maybe you could talk just a tiny bit about that therapy, because I found it so fascinating.
Okay. So first of all, immunotherapy, the research that led up to immunotherapy was awarded a Nobel Prize in 2018. So a professor out of Texas is one of the professors, another Japanese professor as well, won the Nobel Prize for the monumental discoveries that led to cancer immunotherapy. I never, by the way, Jeff, thought in my career I would actually see a time in my lifetime where prescribing a medicine could, without harming the patient, wipe out even metastatic cancer. And in fact, I used it on my own mother and saved her life. She had metastatic recurrent endometrial cancer, and we were able to get an immunotherapy, wipe everything out. 3 treatments over 9 weeks, she had no more cancer. And that's not even a remission. It's basically her body reverting itself to its baseline, essentially.
Right.
It's a restoration of health, as opposed to waiting for the other shoe to drop, which is the chemo kind of concept. Like, we got you in remission, and thank goodness, if we can keep you there for 5 years, you'll probably be okay. We now realize that if you give the body a chance to do what it wants to do, you can achieve remarkable things. So, but here's a problem with immunotherapies. As remarkable as they are, honestly, for many immunotherapies, they only work in about 20% of people. Man, that's terrible. Like 20% of people, who wins the lottery ticket there, right? And if you're somebody with cancer, you want to be somewhere in that 20%. And so this was a big mystery for a long time. Now we're beginning to tease it apart. And guess what? It has to do with the microbiome. So my colleague, Laurence Zitvogel, who's an immuno-oncologist, one of the world's top experts in this area, in Paris, did a study that was published in the journal Science. She looked at 200 people with cancer, various types of cancers, being treated with immunotherapy, these so-called checkpoint inhibitors. And she found that about 20% would respond, and the other ones weren't doing that great. They did not actually respond the way that we wanted. And so she compared every single parameter she could actually find between the responders and the non-responders. Because obviously the finding out what makes somebody a responder is a holy grail. Like, everybody would want to get that. You want to bottle that. And what she found was it didn't matter with genetics. It didn't matter with body size or obesity. It didn't matter with comorbidities. The only thing that mattered was the gut microbiome. And it was only one bacteria that made the difference. People who had Akkermansia muciniphila, mucin because it loves to grow in the mucus, this Akkermansia being a guardian, a primary communicator to the immune system, is key to patients responding to checkpoint inhibitors and immunotherapy. So she found that if they had that, they would respond. If they didn't have that, they wouldn't be a good responder. Now, how do you kill Akkermansia? So easy. If you got a Z-Pack, if I gave you a Z-Pack for bronchitis, which, many patients are on antibiotics for various things, wipes out your Akkermansia. Now you're not going to respond. So one of the things that, I started to do is to figure out how do, Dr. Zitvogel and I actually were talking about this, how do you actually bring back your Akkermansia? Because there's no probiotic for Akkermansia right now. You can't eat it, all right? The only way you can grow Akkermansia is to have your gut secrete that mucus, that healthy mucus, putting fertilizer, loam, rich topsoil back into the garden, the mucus growing. So how do you do that? Well, turns out that dietary factors, these bioactives called elagitanins, which are found in pomegranate, which are found in Concord grape, which are found in cranberries, actually prompt the gut to secrete the mucus, and you can grow lots of Akkermansia. It takes a couple of weeks. But we certainly, for my mother, we certainly made sure that, we gave her Akkermansia. And now patients that I know are testing their microbiome before immunotherapy to see if they have any Akkermansia. Sometimes they can't even remember if they took an antibiotic. And you can grow it with food, with diet. That's the only way you can actually get your Akkermansia to grow. So that's an example of, I had a patient recently who had a blood cancer, was going to get an immunotherapy, but she has a bunch of small kids. They had a infection going through the house. It was like a virus, a bronchitis, the viral bronchitis. They all wound up getting antibiotics, just the regular primary care doctor kind of thing. You shouldn't give antibiotics for viral infections, by the way. But they got them, and she got it too. And guess what wound up happening? Before she was getting on the immunotherapy, I basically asked, can we please check your Akkermansia? So we got a stool sample, sent it off for microbiome analysis, and she had no Akkermansia. None. Not surprising because of the antibiotics. So we basically said, please, let's wait for the immunotherapy until we can build back her Akkermansia. So I got her on pomegranate juice, 8 fluid ounces a day. We had her on it for 3 weeks. That sounds like a long time to withhold a cancer treatment. But I tell you, then we rechecked her stool and she had 6 times above the population average of Akkermansia. So we grew it right back. She had a flourishing garden, a French garden of Akkermansia, got on an immunotherapy, and she became a swift, rapid, complete responder. Her hematologist had never seen somebody respond so well. I'm just giving you a case study, but I'm just telling you, this is based on real emerging science. Why we need to stay on our toes and not assume that we know everything. The science is changing, and it's getting more exciting by the day.
Yeah, if anyone needs any more information or evidence that food is medicine, well, there you go. You just heard it. And, also a lot of these therapies can be combined. You can reduce stage 4 cancer to a stage 2 where it could be more operable, for example. So it's not that you might just eat your way into complete and utter health, though that is possible. But it does seem like having some versatility and flexibility in some of these treatments can really be helpful.
Yeah, no. I want to really, really underscore this for your listeners. So listen, I spent 25 years involved with biotechnology. I'm still involved with it now. I hope to develop 41 FDA-approved drugs and devices for cancer, complications of diabetes, and vision loss. So I'm all about finding the new, better ways to treat a horrible disease, but it's the right person, the right medicine for the right person at the right time. Okay. However, how I got involved with food as medicine is I realized that food was a missing tool in the toolbox, and that while medicine can be delivered in the hospital or in the infusion clinic or in the primary care setting in a doctor's office, in fact, health care is what is being done between visits to the hospital or between visits to the doctor's office. And food is something that we didn't have the right amount of information on. So since I helped to develop drugs, I actually started to study food in the same systems that we develop medicines on, and was able, in fact, to be able to study food and drugs side by side to really, really take a look at food as medicine. And when I say that, food as medicine is so useful for improving your microbiome, for improving your blood, your circulation, for, helping to combat cancer, it is by no means a substitute for standard, best practice, state-of-the-art medical treatment. However, so it's not food versus medicine. What I'm saying is that food is something that every individual is empowered to do for themselves every day before they're sick, when they're sick, after they've recovered from sickness. Whereas doctors and health systems have powerful ways, but limited ways to being able to influence the body itself, whereas food is much more powerful. And if you think about it sort of holistically, it's not food versus medicine. I know there's a temptation to say my kale is better than my chemo. That's not the point. The point is, what about food and medicine? There was an amazing study done looking at young, healthy kids who are getting a flu vaccine. Okay, just normal, healthy kids in college getting a flu vaccine, and they found that if you get a flu vaccine, and by the way, flu vaccines are only about 40% effective in general. Your the response doesn't always kick up. Sometimes it's against the wrong flu. But they actually gave half of the kids in this trial a shake made with broccoli sprouts. Broccoli sprouts contain a natural bioactive called isothiocyanate sulforaphanes. These sulforaphanes activate your immune system with the health defense systems. And they found that actually when they looked at people who got the flu vaccine plus a broccoli sprout shake, that it improved, when you look in their blood, it improved their immune response for their natural killer cells by 22 times. There's no medicine.
Unbelievable.
There's no drug company that could actually ramp up your flu protection like that. So, and when they actually did the diaries of the people, they found those people who also had broccoli sprout shakes just had less symptoms and missed less school, missed less class. So again, this is really it's taking science and putting it wherever it needs to be. And one of the areas that I'm really committed to is actually figuring how to apply it to food, because food feeds our human cells and our microbiome as well.
Yeah. Now, as we make efforts to reform kind of the sick care system to a healthcare system, do you see a future in which, alongside writing scripts for an antibiotic, that you could write a script for broccoli sprouts? And how do we get there if you see that future?
It's interesting. Right now, there is a movement. I'm part of several federal initiatives to help reform our food system and connect it to our health system. And prescription foods are actually a real idea. And you know who's driving it? Our insurance companies, because they're the ones who actually hemorrhage cash for chronic illnesses that aren't made better. And so there is actually an incentive now being provided by some insurance companies for doctors to write prescriptions for patients to receive these prescriptions or write healthier foods. Now, you know, how this actually gets handled at scale or across the country remains to be decided. But, you know, man, I do think that there is a very real future where the healthcare system leans directly into what we get in the grocery store and the farmer's market. And the education, by the way, this is something I'm really, really committed to. Any of the listeners who actually believe in this, like, please come to my website and send me a note and let me know that you're interested in this. And anybody who's a change maker, I would love to know how we can team up. I think what's absolutely critical is that we update, revise the medical education system so that medical students, as they're training, get the same knowledge that we spent the last hour and a half talking about. They need to know it. How come doctors don't know it? So I'd love to be able to be one of the forces that actually helps to transform and update our medical education system.
Yeah. How much nutrition education did you get when you were getting your MD?
I can tell you, I went to a very good medical school and I had outstanding clinical training. I had 1 week of nutrition, and
Yeah.
most people laughed during the course because it was considered kind of like the course that you didn't really need to study for. And at the end of the day, it's the culture. At the end of the day, you're going to actually just write a consult for a nutritionist or a dietitian to come to deal with the patients anyway. It used to be like the subject that nobody really took seriously. I will tell you now, Jeff, that the generation of medical students that are in schools right now, first year, second year, third year, final fourth year of medical school, they're the ones who are actually going to change things. They care about this for themselves. The practicing doctor in their 60s out there, been doing this for decades. We can try to change your mind. But what we really need to do is get back to where the new blood is coming from and get these people to be armed so that they can actually help patients help themselves. That's what's going to make the biggest change in this country from a healthcare perspective.
Yeah. Yeah. Well, good for you and count me on the team for that kind of reform, because, certainly we need it. So leave us today with a couple of key foods, or what are you cooking around the house? What what do you recommend to people as we go into winter and people spending more time inside and making efforts to bolster their immune system?
Great question. So I'll tell you the things that I think about for my own immune system based on the science that I know. Blueberries, which are easy and great for breakfast, ramp up the immune system. That's been shown by blood tests in young, healthy people and athletes. I mean, it definitely works. And you don't need very much, even just like a cup a day of blueberries, which, if you cook down that cup, it's like almost nothing. If you just sat there and snacked on blueberries, it'd be very easy. Dried blueberries, fresh blueberries are fine. Kiwi is another breakfast food that actually is really easy. It's packed with vitamin C, good for the immune system. Most people don't realize that the kiwi is a wonderful source of fiber to feed your microbiome. Eating one kiwi will improve your microbiome in 24 hours. Like that's a payback that also tastes good. I snack on nuts, tree nuts, walnuts, pecans, pistachios, almonds. Those also feed the gut microbiome. I think about I think about the microbiome a lot, which is why I was so excited to come on board to talk about this with you. Nuts are not only a good source of protein, they have healthy fats, and they are a great source of fiber. Mushrooms. I love the taste of mushrooms. Mushrooms are a great source of soluble fiber, good for the microbiome. Beta-D-glucan is what it's called. And that's, by the way, it's also important to know, we're beginning to figure out what these things are that are good. Studies have been shown that eating mushrooms that contain beta-D-glucan actually improve your immune system, starting your saliva and even in your mucus in your nose. That's good defense. You need frontline defense. You need that gate to be pretty strong as well. So those are just a handful of foods. And of course, by the way, so I talked about broccoli sprouts. Well, the grown-up broccoli also can do the same thing. The reason I talk about broccoli sprouts is because this is the odd thing. These sulforaphanes, these healthy bioactives, broccoli sprouts, which are 3 to 4 day old sprouts, you can get them, like in the sprout section of the grocery store, which has become more powerful. Amazingly, they have 100 times more sulforaphanes than the grown-up broccoli. 100 times more. So, you want to if you want to have scalable effect with the smallest amount of volume, some broccoli sprouts you can sprinkle on a salad, you can put into a shake, cook with it, saute with it. What an amazing way to actually activate your. And what I really think that is helpful, that I really want to leave your listeners with is that everything we've talked about when I've mentioned a food is something that comes from a cultural tradition where people make these foods taste awesome, great. Yeah. So for me, I believe that food is one of the most intimate things in our lives. It tells us about our upbringing, our childhood. Everybody can smell something remember the smell of their mom's cooking growing up. It tells us about our family. It tells us about our community. It tells us about our culture. Everybody comes from somewhere today. And a lot of these traditional food cultures, we're already using these healthy foods. We're just rediscovering the science behind them. And because they can be cooked in tasty ways, food has to taste great. It can't be too expensive. It's got to be relatively convenient. And you can take, I write about 200 foods in my book, Eat to Beat Disease. You can find tasty, delicious recipes for these anywhere. And that's what I always tell people: love your food. Gotta love it's got to be tasty. You got to love it. If you love your food and love your health at the same time, that's the 1-2 punch to actually live a long, healthy life.
Hey, thanks for watching. If you liked this interview from the Commune podcast, then I think you'll love this video right here.
We need to change the ratio of repair to injury, and then we will never see a disease manifested by a single bacteria, virus, or cancer, because we changed the terrain for that disease.